In this video, we are going to be doing a power unit 3 work, energy, and power MCQ set. So a 2 kilogram object accelerates from rest to 10 meters per second in 4 seconds. What is the average power delivered to the object? So if we use the P average formula, this is going to be work divided by time. Work is your change in kinetic energy using the work energy theorem. Change in kinetic energy is 1/2 mvf squared minus 1/2 mv initial squared. So this is going to be 1/2 times 2.0 times 10 squared. And this is equal to 1 times 100, which is equal to 100 joules. Now, to find power, you're going to take the 100 joules of work you just found and divide that by your time, which is 4.0. So this is going to equal to 25 watts. Because watts are equal to joules over seconds, so our answer is A. A constant force of 20 newtons moves an object at a constant velocity of 5 meters per second. What is the power delivered by the force? So power is equal to the force times V cosine of the angle theta. So because we have a force that is moved onto an object, we have the force that it is going to be parallel. So when they are parallel, we can say that they're on top of each other, or the angle between them is 0. So you have theta is equal to 0, and you're going to have cosine of theta, cosine of 0, and cosine of 0 is equal to 1. So you're going to have 20 times 5.0, and that's equal to 100 watts. So your answer is C. A machine lifts a 50 kilogram mass vertically at a constant speed of 2.0 meters per second. What is the power output? So your power at a constant speed is going to be equal to the force times your velocity. And at constant speed, you're going to have the force is equal to the mass times the gravity, which is going to be equal to 50 times 10, and that's equal to 500 newtons. So for your power, that's going to be 500 times 2.0, which is equal to 1,000 watts. So your answer is going to be B. A 3 kilogram block slides down a frictionless incline from a height of 5 meters in 2 seconds. What is the average power delivered by the gravity? So work is equal to mgh here. So you're just going to plug in 3.0. Your answer is going to be B. A force does 400 joules of work in 5 seconds while accelerating an object. What is the average power? Your answer is C. A car engine provides a constant power of 200 watts to move a car at a constant speed or constant velocity. If resistive forces double, what happens to the speed to maintain the same power? So power is equal to FV. So this time we would just rearrange for just V. V is equal to power over the force. So your velocity nu is going to equal to your P over your 2F. That's equal to 1 over 2 times V. If your speed doubles. So basically you just put 2F instead of just F. So then what happens is now you have a coefficient in front that is saying it's going to be half of your velocity. So your speed is halving. A force acts on an object such that its velocity doubles while the force remains constant and parallel to the motion. How does the power change? So power is equal to force times velocity, and your new power is equal to force times twice your velocity, which is going to be 2 times FB. So your power doubles because that's what your coefficient is. A 1,000 kilogram car moving at 10 meters per second accelerates to 20 meters per second in 5 seconds. What is the average power during this interval? So when you have average power, this is equal to your change in kinetic energy over your time. So your initial kinetic energy and final kinetic energy have to be calculated, because this is going to be KEF minus KE initial over your time. So you're going to have 1/2 times 1,000 times 10 squared, and that is going to be equal to 50,000 joules. Now for your final kinetic energy, this is going to equal to 1/2 times 1,000 times 20 squared, and that's going to equal to 200,000 joules. So your change in kinetic energy is going to be that 200,000 minus your 50,000 over your 5.0. So you plug that in and you would get in your calculator 30,000 watts. A motor has an efficiency of 80% and outputs 400 watts of useful power. What is the input power? So when you have efficiency is equal to the power that you put out and the power that you put in. So if you solve for your input power, you have P out over your efficiency, and your power out is 400. It says outputs 400 watts, and our efficiency is 80%. So as a decimal, that's 0.80. So that means that your power in is going to be 500 watts. An object is lifted upward at a constant speed by a rope. What statement about power is correct? So if you have constant speed, that means your delta V is equal to 0. So your acceleration is equal to 0. And your summation of forces net is equal to 0. But even though, let's actually put this down here, A is equal to 0. So I don't want to confuse that with the other question. Net is equal to 0. Even though these are the case, work is still being done by gravity. So power is equal to force times velocity. Here your force is going to be equal to mg times velocity. And your velocity is still going to be equal to something that's upward. So actually, let's just... So that means that your power is equal to your force times velocity still.